Kia ora and welcome to another online tutorial. Today we're going to be talking about the Level 1 Science 2018 Mechanics exam, specifically question 2. So question 2A states that Willow and her mountain bike have a combined mass of 82 kilograms. She accelerates at the start of her race at 0.8 meters a second squared. Okay, and they want us to calculate the net force acting on the bike and the rider when accelerating. And if I look at the equations provided, they provide that F net equals mass times acceleration. Okay, an easy one here because they provided us the mass and the acceleration, so we're just going to plug that into our equation. Okay, so it equals our mass, 82 kilograms, times our acceleration, 0.8 meters a second, and we'll get our force acting on her while she's accelerating, which is 65.6 newtons. Okay, nice easy one to start us off, but that's A done. For B, it says draw and label arrows on the diagram below to show all forces acting on Willow and her bike when accelerating. Okay, from our previous question. Now, as you can see, not only am I a fabulous science teacher, but I'm also a pretty good artist. We know that Willow has a weight force, right? And we're going to label that. Now, Willow is not falling through the earth, okay? So she must have an equal and opposite support force, okay? Making sure that our two forces here are the same size, okay? I would heavily recommend using a ruler for this if you've got one, okay? Definitely make sure, to the best of your ability, that the magnitude or length of these arrows is the same. Now, we know she's accelerating. So we're going to say that she has a larger thrust force than the thing acting opposite to that, which for us is going to be resistance. But I'm going to draw on our thrust force, and I'm going to make a good attempt to make it much larger or much obviously larger than the resistance. Remember that every object moving is going to have friction or resistance acting on it, drag. Our main focus here is because she's accelerating, this is going to be larger, okay? And this one here is going to be small. Alrighty. For BII, okay, they've asked us to explain the size of the forces involved when Willow and her bike are accelerating. So again, they're really pushing us here to say that there are unbalanced forces acting upon her. I want to make a bunch of statements. For speed's sake, you would write these out in a much more coherent, full paragraph. Okay, but we're going to say, or we're going to make a note of, forces are unbalanced. Okay, because the forces are unbalanced, there is a net force. Okay, and that net force is acting in direction of motion if our net force is acting in direction of motion, we're accelerating. If it's acting the opposite way, would be decelerating. So we'd say this means Willow is accelerating. No, not acceleration, but accelerating. Okay, so we said thrust is greater than resistance / drag. Okay, and weight equals support. Cool. Now, once more, make sure that you write your answer in a proper paragraph. I'm just trying to point out the main ideas which you want to raise. Definitely jump across, look at the answer schedule if you're struggling to form your answer. Okay, let's move on. So for C, it states that Willow had to choose between two ramps to ride her bike to the top of the incline. It takes less time to use ramp B. For I, it says Or it asks, is the work needed to get to the top of ramp A more or less, or the same as the work needed to get to the top of ramp B? Explain your answer. Okay. We're not going to need a calculation here, but I am going to write down the formula, as always. So, work equals force times distance. When undergoing any vertical motion, we are overcoming weight. Now, we're overcoming that in whatever amount of distance is provided vertically, right? The amount of distance laterally or horizontally is not important to us. Because of that, work is the same, okay? And we mean equal. As both ramps have the same height, okay? Meaning that weight has been overcome the same distance. Okay. As work equals force times distance, and we're overcoming weight going up the ramp, which is acting opposite, okay, it's only ever 0.5 meters. It's going to be the same weight force times the same distance, 0.5 meters. Work is the same. Let's move on to CII. And I just want to state quickly, it takes less time to use ramp B, okay? And I'll make a note of that. Ramp B equals faster. With that information, we can make a good start on this question. So, explain how the two ramps differ in terms of force and power needed to ride up them, okay? So, we're going to start out by writing out our relevant equations. Power equals work over time. Work equals force times distance. Okay. F equals M times A. Right. Now, we're going to start with force, talk about how that adds up to our work, and talk about how that's relevant to our power. Okay. Weight force is the same for both examples as the mass and acceleration due to gravity is constant. Okay. So we talked about force. We said it's the same for both examples. Work, in that case, is the same for both examples as the same weight force has been overcome the same vertical distance. Okay. This is where it gets different because power equals work over time, and ramp B was faster, meaning that we have a reduced time. Okay. Now, if we have a reduced time but work stays the same, that means our power calculation will be greater. Okay. Dividing by a smaller number is going to give us a larger answer. More power is required, or we might say exerted, riding up ramp B as it happens faster. And we're going to make a statement here. Same work, okay, over less time equals more power. So we've said the force is the same because both mass and acceleration due to gravity are constant for this question. The bike and the individual riding it have not changed, and gravity has not changed. The work done is the same because the weight force is the same, and they're both overcoming the same vertical distance. But power is different because the time taken has been reduced for ramp B, while work stays the same, meaning that more power is required or exerted riding up B. Okay, cool. So that's question 2. We've looked at calculating weight, drawing a free body diagram, making sure that we make a special effort to identify what forces are equal and what forces are unbalanced. We've talked about these forces, okay, and how that affects the motion, or we can infer the motion of an individual due to the forces acting on them, and tying it into the observed or stated motion type. We talked about the work leading up to a surface with different length ramps on either side and how it's the same because force is the same and distance vertically is the same. Okay, we expanded on that, talking about why force is the same, why work is the same, but the power is different for that example. Hopefully that helps, team. Hopefully it helps you get out there and get into some physics. Good luck.